Hi everybody, it's Ezekiel. Today we're going to be asking the question, is obesity genetic? Now, to answer this question, I will be reviewing a paper called The Microevolutionary Hypothesis of the Obesity Epidemic by someone called Freeman. Now, what this paper argues is that obesity rates right around the world basically took off after the introduction of modern obstetrics. Now, modern obstetrics is just basically medical care given to women during pregnancy, during childbirth. Okay, so why would modern obstetrics um, cause an increase in the obesity rates around the world? So what they argue is that there's been a shift um, in the gene pool since the introduction of modern obstetrics, um, and a shift that has favoured obesogenic alleles. So the argument that they make is prior to the introduction of modern obstetrics, the maternal mortality rate or maternal death rate, which is defined as the death to the mother during pregnancy or in the 42 days after pregnancy, was about 1 to 1.5% per pregnancy, and then about a 4% lifetime maternal death rate risk. And this was back when women used to have maybe 5 to 8 kids throughout their lives. So quite high, about 4%. Now, also the neonatal mortality, which is defined as death to a live baby within 28 days of birth, was around 14%. Now, they argue that in today's world, that the maternal death rate in modern developed countries for obese women is about 4 times higher than it is for normal BMI women. Now it's still very low. For obese women, the maternal death rate is about um is about 4 in 10,000, whereas for normal BMI women it's about 1 in 10,000. So very low. Um, but anyway, what they argue is that because the maternal death rate has declined so much, it's basically kind of favored genes that are associated with obesity. Like, basically what they're saying is that, like, the type of people that tended to have a higher risk of dying during childbirth in the past were women that were overweight, and the children of the women that were overweight tended to die at a higher rate as well. Um, so basically what they're saying is that, like, obesogenic alleles were just kind of being, like, flushed out of the gene pool um, every time a kind of, someone with obesogenic alleles died during childbirth. Um, so they kind of like make this argument, and they use different figures. So they use African maternal death rates from the 1990s, which were around 10 to 15%, which is like extremely high, but they kind of argue that this is what European countries would have been prior to modern obstetrics. Now, I think these figures are still probably too high for European countries. But anyway, so then they multiply those figures by four, because roughly that's how much higher the maternal death rate is for obese women today in modern developed countries. So they end up with a figure of um, 40 to 60% of a maternal death rate for obese women prior to modern obstetrics. And they end up with a figure for perinatal mortality of about 56% of children born to obese women. So it was 14% prior to modern obstetrics. Then multiply that by four for obese women, and you get 56%. So like very high. So this, they argue, would have just kept obesogenic alleles at a minimum in the population and prevented them from spreading. Um, Now, I yeah, I think these figures are probably a bit too high. But anyway, just for the sake of argument, so they also make this argument that if there's about 1,000 obesity associated loci, and then each allele um increased an individual's risk of zero point 0.1 on the BMI scale, then about a 5% shift in the allele frequency would increase an individual's or a population's BMI by about 5. So technically, if you had this shift, not even a big shift in the allele frequency, just 5%, you could have a population-wide shift of 5 on the BMI scale. So possibly taking a population from 25 to 30. So from being high end of the normal range into the obese range. So yeah, that's basically the argument that this paper makes. Okay, so what do I think of this paper? Do I think it gets it right? So, first of all, I think that this is a good paper. I'm glad that they decided to write a paper about genetics rather than just sticking to the, calories in, calories out sort of model of obesity. Most people that write papers on obesity, can't do that. So what do I think? I think that yes, genetics definitely can play a role in obesity, although I do think they play a relatively small role. So this whole idea of obesogenic alleles becoming more prevalent after the rise of modern obstetrics, I probably think that that is true, but I don't think that it explains the dramatic increase in obesity that's been seen that's been seen right around the world. Okay, so I'll explain a few issues that I have with this paper. So the first one is that it doesn't explain the differences in obesity rates between countries with a with a below the median maternal death rate. So these are like countries like high income countries like the US and the UK. So for example, the US has an obesity rate in 2023 of 43%. The UK has an obesity rate of 25%. So, like, the maternal death rate in these two countries is like exactly the same. It's like well less than 1%, like probably 0.1 of a percent in both these countries. So, that cannot explain like that big of a difference in the obesity rate between those two countries. Also, it's very unlikely that there's just more obesogenic alleles in the US compared to the UK. Um, Another thing I have is that basically just correlation doesn't equal causation. So yes, modern obstetrics was introduced in the 1930s and the 1940s, but what else was also introduced at that time? So cesarean section was introduced at that time, and widespread use of antibiotics was introduced at that time. Now, there's a known relationship between consuming antibiotics as a child, particularly under the age of 3, and even more so under the age of 6 months, and being obese later on in life. Why is that? Basically, because the antibiotics destroy the gut microbiome, and the gut microbiome, is involved in, uh, fat storage, among other things, like supporting the immune system and so on. Also cesarean section, very strong relationship between being born via cesarean section and developing obesity later on in life. So I thought it was unusual that this paper didn't talk about cesarean section and increased rates in cesarean section. Like it is a paper about obstetrics, so I was kind of surprised that it didn't talk about that. Another issue that I have is that it doesn't explain aggressive jumps in the obesity rate in different countries. So, for example, the US in the 1960s had an obesity rate of about 13%. In 1980, it was about 15%. So, small increase in those 20 years. Then from 1980 to 2000, in the year 2000, it had an obesity rate of 32%. So it went from 15% to 32% in the space of 20 years. So just, slow increase from 1960 to 1980, and then a dramatic increase from 1980 to 2000. So again, like the maternal death rate cannot explain that. And the, increased prevalence of obesogenic alleles cannot explain that. Now, they do kind of touch on this in the paper, and they say it's because of those being born post 1940 or post modern obstetrics becoming a bigger and bigger share of the population. Yeah, which is fair. But the thing is, like, if that were true, then you'd expect the obesity rate to just slowly increase year on year on year. There wouldn't be like a slow increase for 20 years and then a dramatic increase for the next 20 years. It wouldn't work like that. It'd just be a slow, steady increase for those 40 years. And it's not just the US that's had these dramatic increases in obesity. There's been other countries that have had, really sharp increases for like 10, 20 years. Another thing that it doesn't really explain is like differences in obesity rates among those with different socioeconomic status. So one thing that you do notice in Western countries, been proven a lot of times, like high income countries, is that those with low socioeconomic status have higher rates of obesity than those with higher socioeconomic status. So is there a difference in maternal death rates between those with low SES versus those with high SES? No, the answer is no, it doesn't. This paper doesn't really explain that. Also, another thing is that if it was all just down to um, obesogenic alleles becoming more prevalent, I would also expect alleles associated with underweight BMI to become more prevalent as well if the maternal death rate had dropped as severely as it did. Now, they do kind of say that, like, yeah, low BMI, it's just very hard to get pregnant with low BMI. But then they do also admit that there has been somewhat of an increase in low BMI people as well. And there has. I've read some papers on that, but it's been a very modest increase, a very small increase. Whereas the high BMI people, like above normal BMI people, have increased dramatically. So I don't think that. Whereas if it was just all about alleles that don't kind of push a person towards normal BMI becoming more prevalent, I would expect there to be more normal BMI people or more underweight BMI people, not just above normal BMI people to increase massively. Um, but yeah, they're the main issues that I have with this paper. Um, if you do want to know like what's really driving the obesity rate, be sure to have a look at my video on antibiotics and then my video on cesarean sections. But yeah, I hope this video has been informative. I hope you've learned something, and I'll see you in the next one.